All right, welcome back, Colts. We're going to continue on with Readiness Assessment 2, numbers 8 through 18. So starting with number 8, this one is saying which ordered pair is a solution of the equation negative 1/4 x plus 6 equals y. And so for this one, we have to remember that our coordinates, like for instance in our option A, that 4 is our x and 7 is our y. Now because of our spacing on here, we don't have a lot of space. And so I'm going to add a sticky note to help us do some of the work, and then I'll move it out of the way so we can see the rest of it. So starting with A, we're going to try it. So I'm going to write down my equation, use a darker color so it shows up a little bit better, and we're going to say negative 1/4 x plus 6 equals y. So for our first option, 4, 7, our x is going to be 4, and our y is going to be 7. So we're going to take them and we're going to substitute it. So I have negative 1/4. I'm going to plug in 4 plus 6 equals, and our value of y is 7. So if you're not sure, you get a little intimidated by fractions, okay, go ahead and use your calculator. But also in this one, because my denominator of my fraction is 4, and then this would technically be 4/1, they're really good buddies. It's going to work out really well. So 1/4 of 4, so think about it that way, okay? What is 1/4 of 4? And we would say negative 1 in this case because it's negative. Okay, if it doesn't work that way, use your calculator to help you, but it's good to practice with fractions because I think you guys can get them with lots of practice. So I'm going to have negative 1. I'm going to bring down my plus 6 equals 7. I'm going to do negative 1 plus 6. When I combine those, I end up with 5 equals 7. Now, don't second guess yourself and think, oh, well, there's a 1 and a 6. Maybe I just messed it up and it should be positive and change it to a 7. In this case, it says 5 equals 7, which does not work, which means A is not one of our options. Okay, so we're going to go through and we'll try B. So for B, I'm going to do negative 1/4. We'll put our coordinate over here, 2, 5. And my x is now going to be 2, and my y is going to be 5. So I'm going to say negative 1/4, parentheses 2, plus 6 equals my y value, which is 5. And now I'm going to say what is a quarter, or negative quarter of 2. So if you like to, you can just multiply straight across the top and the bottom. So I have a negative times a positive. I'm going to end up with a negative 2 over 4 plus 6 equals 5. So if we remember, with our fractions, we can reduce them. So we're going to end up with negative 1/2 plus 6 equals 5. So it's like I have $6, and then I use 50 cents of it. And so I end up with 5/50, or you can say 5 1/2, okay, or an improper fraction. And we say that is not equal 5 as well. So in that case, B does not work. Okay, I'm going to move this sticky note down and get us a new sticky note. So, trying the other ones, we're going to go through and we are going to try C. And then if C works, we're done. Okay, it's always good to check our answers though. So we're going to go negative 1/4 plus 6 equals, and I like to write my coordinate over here, 6, 0, and I like to label it to help me out. So my value of x is going to be 6, my value of y is going to be 0, and I say, all right, negative 1/4 times 6 plus 6. So looking at that one right away, we know that it'd have to be negative 6 plus 6 to equal 0. So we could go through and do the calculations and end up with negative 6 over 4 plus 6, but we know that that's not going to work. That's not going to equal 0. So C also doesn't work. So this question makes us go through all of them. So just to show and to make sure Miss Chandler didn't make a mistake, we're going to write down our coordinate 12, 3, and we're going to say this is our x, this is our y, and we're going to say negative 1/4 times, not negative 12, positive 12, plus 6 equals 3. Okay, so negative 1/4 times 12, this is like 12 over 1, so we're going to end up with negative 12 over 4 plus 6 equals 3. I can reduce negative 12 over 4, and I end up with negative 3 plus 6 equals 3. Negative 3 plus 6 is just going to give us 3, and we end up with 3 equals 3, which works. And so we say, all right, let's pick a brighter color, do some pink maybe, and we say that D works in this case. Okay. All right, going down to number 9. Okay, it's really important. Now some of your teachers, they probably started talking about quadratics. We've talked about absolute value functions. We talked about discrete and different things. So it's really important to know when we look at an equation, if I were to ask you to take this and to graph it, what type of shape does it make? Does it make a line? Does it make a U? Does it make a V? Is it just points? That's what this question is asking. Is it a linear or a nonlinear function? And in this case, because it's in our form y equals mx plus b, just with our b being 0, it is still going to be a linear function. And think of that word right here, line is part of it. Okay, that's all we got to do for number 9. So now we're going to move on down to number 10. Number 10 looks a little intimidating because we got lots of fractions, but all it's doing is taking this equation that's written in standard form here, and if you notice, all of our options have y by themselves. So over here we're going to write 4x minus 6y equals 9. Okay, and I know some of you guys are really good at this. Now some people might like to add 6y, some people might want to subtract 4x. So in our case, I'm going to add 6y so that it's positive. So these cancel out. I end up with 4x equals 6y plus 9 because my 9 is positive. Okay, now I want to get the y by itself, so I'm going to subtract 9 from both sides, and I end up with 6y equals, I'm going to do 4x minus 9 because I want it in that y equals mx plus b format. I'm going to divide both sides by 6. So these cancel out, and I'm going to bring a sticky note in just so we have enough space. So hopefully you guys are using separate sheets of paper because there's not a whole lot of working space. So we end up with 4x minus 9 over 6 equals y. Okay, if you notice, all of our multiple choice options, though, don't look like that. So some of the students have heard it from me, but we do this thing that's called the butterfly method, which means this is divided by 6, and also our negative 9 is divided by 6. And so if I do it piece by piece, I do 4x divided by 6, and then I do a negative 9 divided by 6 equals my y. Well, if I look again, that doesn't really match. But that means I need to go through and I need to reduce my fractions. So I have 4 and 6, and I see those are both even. So I chop them in half. Half of 4 is going to be 2, half of 6 is going to be 3. Now, having that x on top and also on the side is going to be equivalent. So sometimes you'll see it on top or out on the side. Don't get intimidated, that means the same thing. Now I'm going to look at 9 and 6. Now I do have a negative, so I know there's going to be a negative there. And so that tells me, okay, it's possibly going to be this one with a negative or this one with a negative. Okay, you could also go through and say, I have 2/3 already, and look through and say, okay, with D, I got negative 3/2. It can't be that one. This one I have positive 3/2. It can't be that one. This one I have negative 2/3, which is really close. And then this one I have positive 2/3. So you got to trust yourself. You had a positive slope, so keep it positive. But let's see if our value of B matches that. So if I look at 9 and 6, again, like we were talking about, what number goes into both of them? Hopefully you said 3. So 3 goes into 9 3 times, and 3 goes into 6 2 times. So if I look, what I have now matches what I got for A. And that's what we're going to do for number 10. Just a whole lot of algebra. Okay, if I look at number 11, we get kind of scared because there are all these letters and some weird looking cursive L. It's just they make it look like an L so it doesn't look like 21. They make it cursive. And this one they want us to solve for W, which means we just want the W by itself. So I'm going to split it down my equal sign, and I want that W by itself, so I'm going to get rid of that 2L and move it to the other side. So because I don't have a lot of space though, I'm going to move up to this next spot. So I'm going to have P minus 2L equals 2W. So to get the W by itself, I'm going to divide by 2. Now be careful, if you're going to divide by 2, you better divide the whole side by 2. So I'm going to add another sticky note in. And then I'm going to say, all right, I have P minus 2L over 2 equals W. Okay, you can leave it that way, but sometimes there's even going to be other times where it's reduced even further. So again, using our butterfly method, make sure we know that that negative is not part of that P. So let me do it again. So I'm going to do P divided by 2, and then I'm going to do negative 2L divided by 2, all equals W. So my P over 2 is going to stay the same, and then this 2 and this 2 are going to cancel out, so I'm going to say minus L equals W. But either of those options, generally your math teacher will take it. Okay, so that was number 11. All right, moving on, we're going to go to number 12. Now, number 12, it might be really helpful to have a calculator for this one. So in this case, you're just going to go through and you're going to say which options will work for me to find the reciprocal. So you got to remember what a reciprocal is. So some of you guys remembered some skip, flip, multiply stuff. We're not doing that. And sometimes it's good to know about it without having to have things memorized. So a reciprocal is when I have a fraction and I take it and I'm going to flip it. But in this case, we have a decimal, so it makes it a little bit harder. So you got to kind of remember, what does 0.8 represent? So think about it in another way. So one way to do it is that I can take this 0.8 and you can say, well, it's like 80 cents. And so we can convert it into a fraction, something like that. But in this case, we're going to go through and I want you to know that if you set it up to this equation, 0.8 x equals 1, you can solve for that reciprocal using it that way. Okay? And another way to do that is, if I were to actually solve for that, I would divide by 0.8, and I would divide by 0.8. Okay? And C is another way of just saying that operation that we would do in A. If I look at B, I have my 0.8 plus x equals 1. I'm not going to add something to it to make it equal 1. That's not going to tell me what my reciprocal is specifically for it. So in this case, we're just going to get A and C. So that's something a little bit different. We haven't really focused a whole lot on decimals. Okay, going down to number 13. Hopefully it's just as simple as it looks. For this one, we don't have a lot of calculations. You just have to remember what a reciprocal is. Because I have 2/3, I'm going to take it and I'm going to flip that fraction. Be careful not to just include a negative. That's only when we're talking about things that are perpendicular slopes or opposite, which are opposite reciprocals. In this case, I just want the reciprocal, so it's just going to be positive 3/2. Okay, moving on to number 14. So for number 14, I want the opposite of the reciprocal of negative 2.4. So before we jump into the opposite part, let's find the reciprocal. So looking back at number 12, we had the equation where we said 0.8 x equals 1. Well, let's use that, but we're going to use it with negative 2.4. So I'm going to say negative 2.4 x equals 1. So in order for me to solve for x, I'm going to divide this by negative 2.4, negative 2.4, and x ends up being a negative value, and we get negative 0.41667, something like that, right? So if we were to round that to 2 decimal places, it'd be negative 0.42. But in this case, I want the opposite. Do not forget that part. I want the opposite. So what's the opposite of a negative? A positive. So I'm going to end up with 0.42, a positive value. And that's the opposite of the reciprocal of negative 2.4. Okay, moving on to number 15. Number 15 is just asking us which statements are true about this equation, y equals negative 1/4 x minus 2. So we're going to go through it, and it might help you if you were to go through and you were to graph this. This would start at negative 2, and it's a negative slope, and it's a shallow slope because it's that fraction. So it's talking about as our x values increase, the y value increases. So as I go, let's pick a different color. As I increase, as I go this way, is my y getting bigger? Is it going up? No, in this case it's going down, right? Our purple line is going down. If I look again, as the y values of x decrease, so as I go, let's pick a different color for each one. As my y values decrease, as I go this way, what's happening with my y? Is it staying the same? Nope. My purple line is going up if I were to look this direction, not staying the same. And then I go to C. Okay, again, we're talking about increase. As my x increases, my y decreases. So as I increase, is my y decreasing? And yes, we see our purple line is going down. So in this case, we would end up with C. And if you wanted to look again for D, just to continue on, as my x decreases, as I go this way again, as my x decreases, as I'm going smaller and smaller for my x values, is my y decreasing? No, we see that it's getting closer. It's going up. So this one is also not going to work. So we'd get C just by itself for that one. Okay, we're going to jump down to number 16. So hopefully you see right away we look at these and we're like, oh, I know what type of lines those are. Okay, and we see that those lines don't, there's a good joke that some math teachers say, it's Parallel lines have so much in common, but it's too bad they'll never meet. So in this case, our lines are parallel. And how do we tell that they're parallel? Because they have the same slope. Okay, so in this case, we would cross off B because they don't have different slopes. If they're parallel, they better have the same slope. And parallel lines, we also know, they do not intersect. Okay, and then I got to think of this word non-vertical. So remember, vertical is this way. So are these lines not like that? And we would say in our case, yes, they are non-vertical. So I end up with A, C, and D in this case. Okay, and then number 17 builds off of that one. It just says, what is the slope of the line that has a y-intercept of -1? Now technically if you mess this up, you would get the same thing because they both have the same slope. But we want to make sure we understand that y-intercept part. Okay, so if I look here, I want the y-intercept of -1. And I say, okay, is that line positive, negative, horizontal, or vertical? Well, we know it's not vertical because we just talked about that in the previous question, but it's going up. So I'm going to say, okay, if I want to go from this pink point I have here to this one, how many spaces am I going to go up? Well, I see I'm going to go up 2, and I'm going to run 1. So I end up with 2 over 1. We got this nice space over here. And if you want to just check it, do it again. Up 2, run 1. And we see that it hits it again. If I were to check it the other direction, I would go down 2, and I'd run 1 to the left, and it also works. So I end up that my slope ends up being positive 2. Okay, if I jump down to number 18, our last question, which statement about the graph of the equation y equals 2x plus 4 and y equals -x plus 4 are true? So we see right away they have something in common. They have these in common, right? If we remember, that's our b, or another way we say that is our y-intercept is going to be the same. So, A, the graphs intersect the x-axis at the same point. We're like, I'm not really sure. Maybe we'll come back to that one. We haven't graphed it yet. The graphs intersect the y-axis at the same point. Yes, we could say that because they both have the exact same y-intercept. The graphs have different slopes. Okay, look at them. This first one has a slope of 2, and this one has a slope of negative, do we say x? No, remember, we don't want to know about your x's. We just want to know numbers for slope. So that one's going to end up being -1. So the graphs, yes, do have different slopes. And then the graphs, are they parallel lines? Well, just like we saw in number 16, parallel lines means they have to have the same slope. But in this case, they're different, so it can't be that one. So you could go through and you could graph it if you were up here at 4 and you looked at this first one right here and you were saying, all right, I'm going to go up 2 and I'm going to go over 1 and up 2 and over 1. It's going to look something like so. Okay, and then if I was at 4 again, but I was going to go down 1, right 1, down 1, right 1, down 1, right 1, I start to see they do not intersect my x-axis at the same point, so it cannot be A. So there you go. That's questions 8 through 18. Hope it helped.